So last time we discussed the normal distribution, right? We said many random phenomena around us can be explained as a normal curve, right? As a normal distribution. For example, the height of the students in this university, or your grades after the midterm, or the errors which you're doing in the measurements in the physics lab can be all explained using the normal distribution, right? So we considered this example. We said, hey, if you're given some variable x, which has a normal distribution with the mean 10 and standard deviation 5, what is the probability that this x is less than 15, right? So basically, I would like to draw the curve of the normal distribution. So the normal distribution has this kind of curve. We call this as a bell-shaped curve, right? And its function is super difficult. So 1 divided to the sigma multiplied to the square root of 2 pi e in the power of minus x minus mu in the square divided to the 2 sigma square, right? Which is very difficult. So now, if you would like to find the probability that your random variable x takes the value between a and b, what we need to do is we need to find this area, right? In order to find this area, we need to integrate the density function. This is the density function, right? Integrate this from a to the b, which is difficult, right? If in exam I ask you to calculate, to find a probability between a and b, you cannot find this by integrating this, okay? Now, we would like to define one spatial normal distribution. Do you remember last time we discussed how the shape of this curve is changing if I change the mean and the standard deviation, right? So standard deviation is just the square root of variance, right? This is the same thing, okay? So if I change the mean, this curve will just shift to the left or to the right. If I change the variance, if I make this big, it will be smoother, more flat, right? If I make this smaller, the variance smaller, then it will be steeper, right? Around the mean. A lot of points will be around the mean. So depending on mu and sigma, the curve of the normal distribution will be different, okay? Now let's define one spatial variable, one spatial case, when the mean is equal to the 0 and the standard deviation is equal to the 1, okay? Very spatial case. So we call the variable z, if it has the normal distribution, with mean is equal to the 0 and sigma to be equal to the 1, is standard normal distribution. Standard normal distribution. So it has the following curve. So if you substitute sigma to be equal to the 1 and mu to be equal to the 0 in this function, what kind of density function this z will have? 1 divided to the square root of 2 pi, right? E in the power of minus z squared divided to the 2, right? We simplify a lot, but still it is really difficult to integrate this analytically, right? So let's assume your z is given as the normal distribution with the mean at the 0 and standard deviation 1, okay? This is the curve for the z. This is the curve for f of z, okay? Now, I would like to find what is the probability that this z takes the values less than 1. What is the probability that this z is less than 1? What I have to do, I need to find the area under this red curve until this 1, right? Analytically, it should be equal to the integration from minus infinity to the 1 of the f of z, dz, right? Which is still difficult to do. What we can do is we can calculate this numerically, okay? Let's calculate this numerically. If you would calculate this numerically, what you would do, so we've learned in calculus that the definition of the integration basically is like, the idea of the integration was to make a lot of rectangles, right? And by finding the area of each of the rectangle, and by summing all the areas, we can find the area under the curve, right? Okay, so how to find the area of the first rectangle? Here. So if you know the coordinates of the point x and y, the width of this rectangle will be equal to what? To the y, right? Y tells you, not the width, the height, sorry. The height of the first rectangle is equal to the y coordinate of this point, there, right? If I give you x, is it possible to find the y coordinate of this point? How? I just need to evaluate the function, right? This f of z. So instead of z, I need to put 1. It gives me the y coordinate of this point, right? Which is the height of this rectangle. Then I need to multiply this to the width, which is delta x, right? So we define this fixed. We define this by ourselves. Then this will multiplication of the delta x to the y coordinate of this point gives me the area of this rectangle, right? Then by summing all the rectangles, the areas of all the rectangles, we can find the area under this curve, okay? So let's assume I would like to ask you to write a computer program which finds me the probability until some point z, okay? Any point z, not until 1, until any point z. So do you remember this kind of distribution is called the cumulative distribution, right? Cumulative distribution is the probability until some specific point, right? So since this distribution z is spatial one, we're going to denote its cumulative distribution also spatially, okay? So let's define this as the phi of z. This is the integration, or phi of x, sorry, from minus infinity until the x, f of z dz, okay? So for example, in this case, it would be phi of 1, right? Which is the integration from minus infinity until the 1, f of z dz, okay? So what you need to do is, you need to write a computer program which gets as the input the x, okay? And tells me as the output as the phi of x, okay? It tells me what is the area under the curve of the standard normal distribution until this point x, which is calculated numerically, okay? You will calculate this, I mean, in a computer, we can calculate a lot of integrals, okay? By numerically, okay? Do you understand the idea how to do this? You create a lot of rectangles, and sum this, you will get the answer, okay? Now let's assume you made a computer program at home, okay? Now, the next step would be, if I ask you to calculate some probabilities for the standard normal distribution in the exam, either you need to use the computer, right? If it is not allowed, what you would do? If it is not allowed to use your computers, so how you can use your program? What you can do is, you can make the table, right? Big table with a lot of values of the z, and the areas corresponding to that z, right? For example, you will make the table of the cumulative distribution, f of x, okay, in x. If, for example, x is equal to 0, what is the value of the phi of x? Or 1, or 1.2, okay? For example, we know that the when the x is equal to the 0 here, or when the z is equal to the 0, it splits the area exactly to the 2, right? Because this is the maximum point there, right? If I know that the total area under this curve is equal to the 1, total area under any density function is equal to the 1, what is the phi of 0? What is the area until 0? What is the area until here? 0.5, right? If the total area is 1, then the area, half of this area, is equal to the 0.5, right? You will make the table like this. You will calculate this using your computer program, okay? So for example, you calculated that this is equal to the 0.5. Then numerically, you calculated that the area until point 1 is equal to the 0.84, for example, okay? Until here is some number. You did this table, right? And you can bring this to the class, okay? Once you have this table, it appears you can calculate any probabilities, roughly, more or less, right, in the exam. So if I say, hey, what is the probability that z is less than 1, what you will do? Or x is less than 1, or z is less than 1. You will need to go to the table, right? So this is phi of 1, right? Because z is less or equal to the 1. This is the cumulative distribution until 1, right? You will go to the table, you will find a value of the 1, which is equal to the 0.84, right? So this will be equal to the 0.84. Yes? Do you understand how to do this, roughly? Yes? So what if I would like to ask you to find me the area between the 2 points, between 1 and 0? 1 and 0. What is the area here between 1 and 0? How to find this area using this table? Yes. So the area between 0 and 1, this is, you need to find the area until 1, right? Find the area until the 1. Then subtract from this the area until the 0, right? It will tell you the area between. Do you understand this? Yes? So for example, if you have the bottle of the water, right? I would like to know how much water consists here in this region. What you can do? You can find you can figure out how much water you need to fill until here, right? How much water you need to fill until here. If you subtract the amount of the water from here, from this, it gives the amount of the water here, right? This is the same idea. If I would like to know what is the area between 0 and 1, I can find the area until 1. I can find the area until 0. If I subtract them, it gives me the area in between. Yes? So do you see? So using this table, I can find the probabilities for almost all the numbers for the standard normal distribution. Okay, so this is equal to 0.84 minus 0.5, which is equal to the 0.34. Okay? Now, if you print out this table and come to the exam, will you be able to find the probabilities? Yes? The only problem is like this. This table, this is 1D table, right? 1D array, right? So do you understand this? What does it mean? Like just the 2 columns. And like the numbers are given there and the values of the functions are given there. If you print this to many values of the z, it will be really long, right? I would like to use A4 paper, okay? In order to make this in a compact form, we can put the values of the z in this form. In this form. Okay, so in 2D table, okay? What does it mean in this 2D table? So if you would like to calculate what is the area until some point z, you need to use the first column and the first row, okay? So what you need to do is you need to add the number from the, you need to choose the number from the first column, you need to choose the number from the first row and add them, okay? So this, and their intersection gives you the area. Okay? For example, if I ask you, what is the area until 0.75? You will need to choose 0.7 from here, from the first column, right? Then you need to choose 0.05 from the first row, right? The intersection is 0.7734, right? It will give you the area until 0.75, okay? So we can make this table, 2D table, in order to save the space in the A4 paper, right? But the idea is the same, okay? Now, the whole table can be printed in the 2 pages. In exam, hypothetically, you can bring this paper and calculate any probabilities without actual integration or without numerical integration either, right? Just using this table. Do you understand the idea? Yes? Okay. So for the standard normal distribution, we can calculate the probabilities using this table, okay? Now, what if your distribution is not standard? What if, for example, in this case, the probability, we need to find a probability where the mean is not 0 and the sigma is not 5, is not 1. What do I need to do? I need to shift, yes? So I need to shift every single x to the z so that the areas will be the same, will remain the same, right? Like this. So if you're given the x was the mean 10 and with the standard deviation 15, then I need to shift this 10 to the 0. Then I need to shift this 15 to some number so that the areas until 15 will be the same as the area until here. Okay? So since I know how to find the areas here, I can find the areas here as well. Okay? This is the idea, conceptual idea. So we will learn how to do this technically. So you just need to understand the problem. So do you remember in calculus, for example, we calculated the integral sometimes in different coordinate system, right? So sometimes it is easier for us to integrate in the rectangle coordinates. Sometimes it was easier for us to integrate in polar coordinates, right? The point was integrating this function is easier in the polar coordinates, right? Or in linear algebra, we talk about the SVD, for example, right? Instead of solving the problem in the real space, we could project everything to some new space and solve it there, right? The idea is here the same. So I would like to shift all the outputs of this x to the z so that the areas will be the same. And since I know how to calculate the areas for the z, it means that I can calculate everything for the x as well. Okay? Now I just need to figure out what is the correspondence between the x and z, right? What is the function which transfers the numbers from x to the z? Yes? Do you understand this? Okay. Here, in the first table, I will give you the idea, then we'll try to do this mathematically as well. Okay? Do you know how we can measure the distance? We can measure the distance in many different ways, right? We can measure the distance in kilometers, in many different units. We can measure the distance in kilometers, in meters, in centimeters, in time, in money, right? In many things. Let's measure the distance between the 2 points here in standard deviations. Okay? So could you please tell me, if the mean is equal to the 10, if your point is 15, if the standard deviation is 5, how far this 15 is from the 10 in standard deviations? Standard deviation is 5, your point is 15, mean is 10. How far this point 15 is from the 10 in standard deviations? In standard deviations. One standard deviation far away from this, right? Do you understand this? So this point 15 is exactly one standard deviation far away from the 10, right? So that is why here this should be equal to the 1, okay? So this 1 is one standard deviation far away from this 0, because standard deviation here is 1, right? I would like to shift the points depending on the distances in standard deviations. That's the idea. We will do this mathematically now, okay? So let we're given x with the normal distribution, with the mean mu and the variance sigma squared. I would like to transfer every single output to the z with the normal distribution, with the mean 0 and standard deviation 1. Okay? Okay? So I would like to do this linearly. I would like to write down, hey, if I'm given the x, in order to get the corresponding value in z, I just need to multiply this x to the a and add the b. Okay? If I give you, for example, x is equal to the 15, in order to get z to be equal to the 1, I'm going to multiply this 15 to some constant a and add some constant b. Okay? So what was do you remember we talked about the expected value of the function of the x, right? So the expected value of the z is equal to the expected value of the ax plus b, right? If you open up the brackets, what you will have? A multiplied is the expected value of the x plus b, right? So a multiplied is the mu plus b, right? So by the definition, the expected value of the z is equal to what? To the 0, right? Yes? So the expected value of the z is equal to the 0. What is the variance of the z? This is the variance of ax plus b. Previously we calculated, we showed that the variance of the ax plus b is equal to a squared multiplied to the variance of the x, right? The variance of the b will be just simply 0, okay? So the variance of the ax plus b is equal to the variance of the a squared multiplied to the variance of the x, which is equal to the a squared multiplied to the sigma squared. This is the same sigma squared as here, okay? Which should be equal to the 1, right? So the variance of the z here, the expected value of the z, this is the variance of the z, right? The variance is equal to the 1. From this system, we can find the a and b, okay? So from the second equation, I can figure out that a is equal to the 1 over sigma, right? Yes, if you put the a as a 1 over sigma, the left-hand side will be equal to the right-hand side. Now let's substitute this A to the first equation. It will be mu divided to the sigma plus B is equal to the 0. What's the B from here? Minus mu divided to the sigma, right? I found A and B, okay? So I found a correspondence between the Z and X. So Z is equal to A, which is 1 over sigma multiplied to the X. I'm substituting everything to here, right? Minus mu divided to the sigma, right? Or X minus mu divided to the sigma. This is the correspondence between the X with any normal distribution, and Z, which has the standard normal distribution. Okay? If you have some X, if you subtract from this X the mean and divide this to the sigma, it gives you the distance from the mean in standard deviations. Okay? This is the distance of the X from the mean in standard deviations. Okay? For example, in our previous example, if the mean is equal to the 10, if the sigma is equal to the 5, if the X is equal to the 15, what will be the Z score? Z? 1, right? 15 minus 10 divided to the 5 is 1. Okay? So now the idea is like this. If I would like to calculate the probabilities, I just need to transfer every X to the Z and calculate this using the table of the Z. In the beginning of the lecture, we've learned how to do this, right? Let's do an example. Do you understand the conceptual idea? Okay. So let's say after the midterm exam, I've calculated that the average score is 78. Okay? So how technically I need to calculate the average score? Technically, I need to find all the scores of all the students. I need to sum them and divide them to the number of students, right? It will give me, let's say, 78. And the standard deviation is 8. So do you know how to calculate the standard deviations? How? So I found a mean, right, 78. What I will do is I will subtract the 78 from each score, okay, from each result of each student, okay? Then I will square them. Then I will sum all these numbers and divide this to the number of these students. It gives me the variance, okay? Variance is equal to the 64. Then if I take the square root of the 64, it gives me the standard deviation, 8. Okay? Let's assume that after the midterm, the mean is equal to the 78, and the standard deviation is equal to the 8. Now, if I choose one of the students randomly, for example, him, what is the probability that his score is between 60 and 80? If it is given that the scores of the students have the normal distribution. Okay? What does it mean? It means that after the midterm, I usually expect that a lot of students will have like average scores, right, or around the mean. Very few will have like a really high scores. Very few will have the low scores. Okay, so if the distribution of the scores, X here is the random variable, which is the score of after the midterm. Okay, so X is random, right? For example, after the score, after the exam, this might be 80 for him. This might be 85 for him, right? This is random. After the midterm, what is the probability that his score is between 60 and 80. Is it clear the problem? We calculate it like this. So let's do an example. X has the normal distribution with the mean 78, with the standard deviation 8. If I ask you, if I give you standard deviation 8, what is the variance? What is the variance of the X? 64, okay? Variance and the standard deviation are just like the same thing, but you need to take the square root from the variance in order to find the standard deviation, okay? Now I'm asking you, what is the probability that if you choose one of the student score, X, it will be between 60 and 80, right? In order to calculate this, we need to transfer all the numbers to the Z scores, right, to the Z table. So if I subtract the mean from all of the three parts of this inequality, nothing will change, right? So this will be 60 minus mu less than X minus mu less than 80 minus mu, right? This probability is the same as this one, right? Because I'm subtracting one number from all the terms of this inequality, right? Now let's divide all the terms of this inequality to the sigma, okay? So this will be probability of 60 minus mu divided to the sigma less than x minus mu divided to the sigma less than 80 minus mu divided to the sigma, right? So previously we defined this thing as what? As the z, right? So probability that x is between 60 and 80 corresponds to the probability of the z in between which numbers? So the mean is equal to the 78, right? And the sigma is equal to the 8, right? If you subtract the 78 from the 60 and divide this to the 80, it will be minus 2.25, right? And if you subtract the 78 from the 80 and divide this to the 8, it will be 0.25, right? So it appears finding the probability for the x between 60 and 80 corresponds to finding the probability for the z between minus 2.25 and 0.25, right? And in order to find the probability, what I need to do is I need to find a value for the phi, which is minus 0.25, right? And subtract phi at the minus 2.25, okay? Let's go to the table and find this. So I will need to go to the table and find the value of the phi for the 0.25, right? So I need to find the 0.2 from here. Then I need to go to the 5 units there, right? Here. The intersection gives me the area until 0.25, okay? So the area, like this is the z table, right? You will need to choose the area. Z, for example, z is equal to the 0.25. This area, shaded one, is, it appears, 0.59 and 87, okay? So this is equal to 0.59 and 87. Let's figure out what is this. Okay? So in order to do this, I need to go to the left part, right? I need to find 2.2, right? Then I need to go again 5 units, right? This is 5, 0.5. Minus 2.2, then 0.5, right? So this number is intersection between minus 2.2 and 0.5. Okay? So this will give me the area until minus 2.25. Is it clear how it works? Okay. So this is equal to the 0.0122. 0.0122. If you subtract this, you will get the answer. Okay? Like this. So the idea is like this. If you're given the normal distribution x with this density function, probability that x is between 60 and 80 is this area, right? What we will do is we will transfer the 60 to the z square, right? It will be minus 2.25. We will transfer this 80 to the z square. It will be 0.25. And the area in the z distribution between minus 2.25 and 0.25 will be the same as the area between 60 and 80 for the x, okay? And this area is equal to the 0.58 and 65. Okay, so it appears we can calculate the probabilities for the normal distribution even without the integration, right? So the only thing which we need is the table, right? Okay. And this table is also calculated numerically, okay? So people calculated areas numerically. Now let's do one more example. So let's say, assume that the lifetime in some region of Uzbekistan has standard deviation 14. Okay, so we somehow calculated the standard deviation. We don't know what is the average lifetime in that region. Okay, what is the average lifetime in this region? If I know that the 30% of the population in this region had the lifetime more than 75 years old. 30% of the people in this region have the lifetime more than 75 years old. I just need to know what is the average lifetime, which is a little bit different from the previous one, right? So let's do this together. So let's say x is the random variable. Here it means that lifetime, right? It has the normal distribution with some mean, which I don't know, with the standard deviation 14. Okay? I know that if this is my population, 30% of the population have the lifetime more than 75 years old. Okay? What is the probability that X is more than 75? Oh, okay, so I will make this question differently so that you can answer. So let's say you have the box, okay? You don't know how many balls there are inside the box. But you know that 30% of the balls inside the box are red. What is the probability that you will choose a red ball? 0.3, right? Or if you can make this with a number. So if you don't understand this percentage, just make the numbers, okay? So let's assume that inside the box there are 10 balls, 3 of them are red. This is exactly 30%, right? So what is the probability that you will choose the red ball? 0.3, right? If you know that 30% of the population have the average lifetime more than 75 years old, it means that the probability that lifetime is more than 75 is equal to 0.3, right? 0.3. So I don't know how to calculate the areas after some points, right? I know only how to calculate the areas until some point, right? So that is why, for me, it would be interesting to know what is the probability that X, the lifetime, is less than 75. What is this? 0.7, right? 1 minus probability of X is more than 75, right? Which is 1 minus probability of X is more than 75, okay? Again, I need to calculate the probability somehow, okay? So probability of X is less than 75 is equal to the probability of, let me subtract the mean from both sides and divide both sides to the sigma, okay? It will be X minus mu divided to the sigma, less than 75 minus mean divided to the sigma, right? Which is equal to the probability of Z, so this is Z, right? Z is less than some number, 75 minus mu divided to the sigma, which is equal to 0.7, right? So let me draw the curve of the normal distribution in order to try to understand what I want, what I need to find. So let's say this is the curve of the standard normal distribution, okay? It tells me that the probability, the area until this point, 75 minus mu divided to the sigma, the area until this point is equal to what? 0.7, right? What is this point? This is the question, right? Previously, we choose some points on the z-axis and we said, okay, so what is the area until those points, right? Now, I'm asking you a question differently. I'm saying, hey, if the area until your point is equal to the 0.7, what is this point? Again, I need to go to the table and find what? 0.7, right? But from the middle, right? So I need to figure out the value for the z so that the area will be equal to the 0.7, okay? From this table, I need to find a value which is closest to the 0.7, okay? So because I don't have exactly 0.7. 0.7. 52, maybe it's closer. Yes? 52. 0.52 is closer, right? Okay. Do you understand this? So if I choose the z to be equal to the 0.52, then the area until this point will be equal to 0.7. Okay? If I choose this point as 0.52, then the area will be equal to the 0.7. Do you understand this? Gia? No? Okay. So if I choose 0.52, right, the area until there, it will be 0.7 roughly, right? Okay, so it appears 75 minus mu divided to the sigma is equal to the 0.52, right? So I am given sigma, which is equal to what? 14, right? I need to find a mean from here, which is like a doable, right? So let's find a mean. So mean is equal to 75 minus 14 multiplied to the 0.52. Can you calculate this? So which is roughly 67 point something or 66 point something, right? Roughly 67, right? Okay, so sometimes I'm asking, we might be asked to solve this kind of problems, okay? So we know what is the area, but we need to find the points. Okay? So using this table, we need to be able to find both the points and the areas. Okay? If I give you the points, you need to tell me how to find what is the area. If I give you the area, you need to also be able to find the points. So now let's solve the problem, which contains both of the types of this kind of problems. So let's say, what do you think? Is the time which is needed for the students to finish the midterm exam, is it different for all the students? For many? For many it's different, right? So if the time is not limited, okay, let's assume I will distribute the midterm papers, and you will submit this when you will finish, okay? And I'm going to measure the time for each of the students, okay? So, I mean, it would be logical to say that this distribution, the time which is needed to finish the midterm exam, has the normal distribution, right? Because usually for many people, this is around the average. For some people, this is too fast. For some people, it is too long, right? So let's assume that average time for each student to finish the exam is 80 minutes, okay? With the standard deviation 10 minutes, okay? And it has the normal distribution. What I want is, I would like to know what proportion. Now, if I limit the time for the exam, okay, you will all go to the exam, you will start writing the exam, and if you finish before the 90 minutes, you will submit this. If you didn't finish this, you have to stop there after 90 minutes, okay? So what proportion of the students will finish the exam within 90 minutes? Is it clear the question? Yes? So if I know that in average it takes 80 minutes, in average it takes 80 minutes, it doesn't mean that you all will finish in 80 minutes, right? Some people will finish before 80 minutes. Some people will finish this after 80 minutes, right? So I just would like to know, within 90 minutes, what is the percentage of the students will finish in 90 minutes? So in order to do this problem, so let me try to do the distribution. So now the example. So let me draw this first of all. So let's say this is the x, right? X is the time which is needed to finish the exam for each student, right? It has the mean 80 minutes, right? It was the standard deviation 10 minutes, right? I would like to know how many students will finish the exam within 90 minutes, okay, in percentages. So I need to choose the point here, 90. Then I need to find the area here, right? Because do you remember last time we discussed that this red curve can be explained as the frequencies, right? The number of the students, right? The number of the cases with this time, right? Then this area will tell you the amount of the students, right, who finish the exam within 90 minutes, okay? So I would like to know how many students will finish the exam within 90 minutes in percentages, right? So what is the proportion of the students will finish the exam within 90%? This is finding this area, finding this probability, right? So basically, we need to find the probability that x is less than 90. This is what I need to do, right? So in order to calculate this, we can calculate probability of x minus mu divided to the sigma is less than 90 minus mu divided to the sigma. Right? So what is x minus mu divided to the sigma? Is z, right? Probability of the z is less than 90 minus, what is the mu? 80. What is the sigma? 80. Oops. 80. -80 minus